Alright, hello everyone, and welcome back to this tutorial video. Well actually, I'm not welcoming you back to the same one, we've already done a few, but this is going to be our 7th. Alright, so what we're doing today is we're going to be wrapping up our CAD unit. And I think, what we've covered so far should be, enough for us when we progress onto our projects unit. But today I just want to kind of, conclude everything and put it up, wrap it up in a bow quite nicely. So what we'll be doing today is a bit of a project with a little bit of everything, but luckily you guys won't have to do any thinking because I know that's very hard. We'll pretty much just do everything as instructed, right? There will be a reference, so you won't have to do any design, just CAD, right? So this is going to be an example of doing CAD independent of doing design because you're going to be basically just copying or recreating a reference design. So let's go ahead and get started, right? Most robotics assemblies are just collections of modified imported parts. And so what we're going to be doing today is using some of these in an actual robotics assembly context. And the aim of this was to isolate the CAD and not really talk about the design, right? We're using CAD in an FRC context, but we're doing it without the extra design thinking there, right? So what we're going to be doing is we're going to be going onto our robot from 2020, and we're going to be creating climb hooks, right? It's a pretty simple creation, pretty simple mechanism, but this is, a task-based feature, but we won't actually be doing any design, right, to back this up. This is just going to be us, just following a reference pattern and creating that, but I think it should be quite helpful combining parts and assemblies as well as common off-the-shelf parts. So with that said, let's go ahead and get started, right? So we'll go to our Onshape real quick. Just over here. I already have it open, but if you don't, you can open it now. And then we'll go to the team, and we'll go to off-season 2020. And what we have here, if we go to presented practice documents, is we have our climb hook creation activity. So that's what we're going to be doing today, right? And I'm going to go ahead and make a copy, and I'm going to name it my name. Hey, wow, I'm really improving at spelling. I'm pretty proud of myself there, but yeah, we'll go ahead and create that. And then as it starts to open, we'll go back here and we'll move it to our team member folder. Because Onshape will auto-open documents, there may be a way to change that in the settings. I'm not entirely sure about that, but yeah, we'll go ahead and wait for that to auto-open. And now it's auto-opening. We'll go back to Onshape here, and we'll go ahead and move this into our team member folder. We'll move it into there. And now we'll go to our team member folder, and we will open up this document. This is going to be down here at, it's going to be climb hook creation activity, Lucian Genova. I'm not sure. Yeah, it's going to be this one. So what we've got here is we've got a document, right? And this document has our completed robot CAD inside of it, as well as some reference CAD that we'll be able to work off of. So the task today is to create CAD for a climb hook for these, right? Now you can see in 2020, basically the aim of climbing is there's a bar that you have to raise your elevator up and latch onto, and then you lower your elevator back down and pull your robot up. You pull your robot up by lowering your elevator. So now you can't really do anything if you don't have any sort of hook on the elevator like that. So we can see this hook here, right? It's sort of over-engineered, sort of thick. It's quarter-inch aluminum here. This is aluminum plating, right? And let's go ahead and analyze this design real quick. We've got quarter-inch aluminum plates. It looks like these have been custom manufactured. Doesn't look like a cost part. Then we've got 2 of these stacked in each hook, and then it looks like we've got half-inch hex. Let's go ahead and check that sizing there. Measure from there to there. Yeah, so that's going to be half-inch right there. That's going to be, standard procedure as far as making standoffs. A standoff is something that, like, you put around a bolt. That X is basically a spacer. So then I would imagine we're going to have quarter-inch holes to match with that hex. Yes, we do. Okay. And then now we've got these brackets here with corresponding holes in the hooks, which mount to this top bar here, which is 2x1 aluminum. All right, that seems pretty standard procedure, so let's go ahead and replicate that. So let's first look for the folder in here that says completed climb hooks, right? We're going to wind up adding these to the elevator assembly, right, like this. and then that will add into the main assembly. But let's look at the climb hooks, and we'll go to our hook assembly. All right, so we've got this. Right, it seems pretty straightforward. It's just what we analyzed there. And let's go ahead and look at the parts that we've got in there. We've got a hook plate, we've got 1/2 inch hex, and we've got a corner gusset there, which appears to be AM would stand for Andy Mark. But we'll do some treasure hunting on our own to find a gusset that works, because this isn't the only one that will work for the purpose. I'm sure there are others. So yeah, first things first, I think we should make the hook plate. I think that might be the best way to start off, just because then we have some architecture to base everything else off of. So let's go here, back to our home page there, right? So this elevator is asking us to add hooks, and then this is a complete bot with this elevator assembly inside of it. So if we add hooks to this, then the elevator with hooks will be in this. So first things first, let's go ahead and make a folder, and we'll title it climb hooks. We'll title it climb hooks for now. And we'll go in here, and let's make a part studio. Right, we'll go in here and we'll make a part studio. And this part studio, we will rename that. We'll name this hook side plate. Right, that's what we'll name it. So first things first, I keep saying that a lot, but we should put the first things first, because that's where they go. So yeah, first thing, about to say it again, I gotta smack myself, but yeah, so let's make a sketch. Right, we'll select the top plane here, and we'll go ahead and create our sketch there. And we'll go to the top here, and we'll create, well, first things, I'm just gonna name this, we'll name it boss base, right? And this is gonna be the base sketch that we're gonna base everything else off of. So we're gonna go here, and we're gonna click a center point rectangle. I think that's usually gonna be the best thing to do, just because a center point rectangle allows you to keep everything centered about the origin. And I don't know, estimating what I saw with the hooks, we'll go ahead and make it like 6 by 4 inches. I think is a healthy estimate for now. And then we'll go ahead and extrude that to what we know the depth to be, which is 1/4 inch. And we can double check that in measurement, but it is 1/4 inch aluminum, which is quite strong, by the way. Usually we use 1/8 inch, but these hooks, you know, it's not a lot of extra weight, and you know, underbuilding them, making them too weak, has some pretty bad consequences, right? They might bend and break, and your robot would fall down, which would be pretty bad. So yeah, we'll make that 0.25, right? Or you could do 1 divided by 4. It's the same thing. All right, so now we've got our boss base plate there, and we can go ahead and hide all this reference geometry. Now, when you're following along in CAD, don't hesitate to just pause the video and do these. I would much rather you be in the same spot as me than, you know, trying to catch up the whole time. If you're just watching, that's fine. I'll try to move through these things as quickly as I can. Just try not to take too much time. But yeah, okay. So first things, we're gonna go ahead and edit the appearance, because I like things that look pretty. So we'll make it like this gray color. No, let's go ahead and make it this silver color. This looks more like aluminum. So yeah, now we've got our silver aluminum, and let's go ahead and examine the dimensions of the original hook side plate. And we'll go here to completed climb hooks, and we'll go to hook plate here. All right, so what are the dimensions we want? Let's see. So let's first check the length. Right, we'll go from here. If you just select this plane, and here if you select this face as well, unselect that. It will work that way, but it's better to select 2 parallel faces. So let's check here. Parallel distance 7 inches. Okay, so that's close to what we got. If we go here and we can look at our dx, right, distance x, that's going to be parallel with this x-axis, so we know it's not trying to find, like, you know, some sort of dimension on an angle that, you know, won't give us an accurate reading. So yeah, 7 inches seems to be accurate, and let's go ahead and also find our height. And we'll go here and we'll click both of these, and that's going to give us 3.5 inches in the y direction, which is perpendicular to x, so that makes sense, right? All right, so 7 by 3.5. Let's go ahead and go back to our climb hook here, and we'll go ahead and change the dimensions in our sketch here. So this is going to be 7 inches, and this is going to become 3.5. All right, just like that, 3.5. Now the next thing we're going to need, and let's go ahead and back and examine our completed hook. And you know what, let's actually just go ahead and open this in a new browser tab. I think that'll allow us to operate a little bit more smoothly, as I can just switch between these instead of having to cycle through the tabs each time I want to find something. So yeah, here we've got our hook, and let's try to identify some of the main features on here. First things first, and I said it again, but this time I actually mean it. We've got our little climb geometry here, right? So this is going to fit around the climb bar, and this is going to help guide this hook onto the climb bar, right, as it lowers down. So it's up here on the top of the robot, climb bar is down here, and this lowers down onto the climb bar. And if it's like a little bit off center, if the climb bar is here and it lowers down onto the climb bar, it's going to guide itself, right? It's going to guide itself into the hole there, and that'll give us some nice, it's a bit of a driver assist in that way. And then you can see we've got some thick edges around these holes, just for some strength, right? The thicker this is, the stronger it's going to be here. And then we also have these holes for standoffs, which are 1/4 inch, as we've determined before. And then we've got these holes for bracket mounting, which we won't add immediately. We'll add those later using a new feature I'm going to show you guys. Or it's not new to the software, but it's quite useful. All right, so there we go. I think the first thing we should add is this hole here. So let's find, first thing we want to find out about it is the dimension here, right? The radius, or the size of the circle. And that's going to be 0.875, so double that, it's going to be 1.75, I believe. That seems to be about correct. So 1.75 diameter circle that we'll put up here, and let's see what dimensions it is away from. Well, we could dimension it. We just want to dimension it from two sides to give it x and y coordinates, right? So it's accurately placed. So we'll go from here. See, we don't want the minimum distance. See, that's the distance between the closest point and the wall there. Let's find that again. Hold on. Yeah, we'll find that again, and we'll go here and we'll look for dx. Which is going to be 2 inches. All right, that's pretty useful. Let's unclick that and click this top edge here, and it's going to be the same thing, 2 inches. Awesome. So it appears that there's a uniform spacing there. Whoever designed this, which actually was me, but whoever designed this was clearly trying to leave a lot of room for strength in between this hook. Or this whole thing could be shorter, but then it would be less strong because the main load-bearing area is going to be right here, as well as potentially right here if your robot swings backwards, right? If your robot's, when you hang on this part, if it sort of swings this way, right, then your load is going to go sort of translated into this area. So you want this to be thick. You do. Okay, so it's 2 inches away from the top and 2 inches away from the right with a radius of 1.75. We'll go ahead and translate those dimensions into our CAD with a new sketch. Let's make this sketch, and we'll title it Climb Grip, maybe? We'll call it Climb Hook Infrastructure. And then we'll select this plane as our sketch plane. Oh, you got to click that and then click this. All right, so we're going to select this plane, and we'll go ahead and we'll start with our circle. Right, we'll go up here and we'll make a circle. Make sure you don't snap it to anything because it may make it tricky to dimension stuff later. Just make this circle about the right size like this, and we'll dimension it to 1.75. And now we've got to dimension it from the edges. So we'll use D because we're gamers, right? We use keyboard shortcuts. And then we'll dimension it to this wall here, 2 inches. And we'll dimension it to this wall up here, which is going to be the same, 2 inches. Just like that. And this dimension, if you checked it, would be 1.5. Okay, so now we've got this hole, right, but we can't get to it, so what we're going to have to do is check these geometry points. And I'm fairly certain that this point is parallel with the center point of the circle. This looks like a half circle to me. We can always check that, right? If we check this distance here to here, we know that the center point of the circle to the base there is 1.5 inches. So if this is the same, yeah, 1.5 inches, right? If we check this as well, it should be the same value, right? Because we're measuring to the base of the plate there, right? So measuring from the center, and if this is parallel with the center, it'll be the same distance. So we know this is, a semicircle like that, and then this appears to go here, and I would guess that this is going to be the same distance, the same thickness as the bar that it's mounted to. So that's going to be 2 inches. Go ahead and fact check that, and we're correct, 2 inches. I'm on the money today, we got this. And then this appears to be tangent, right? So that's just going to come off from where the center line is because it is a right angle. If you check this and this, it should be a right angle, 90 degrees like that. Awesome, 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 awesome. Okay, so let's go ahead and make this geometry in our CAD. All right, so we'll make a line, right? And I used L to make a line, but you can go up and click here if you want to. and we'll hover over this center point just so it gives us that as a snap, and we'll go, keeping that dotted line there, we'll go to the edge of this circle here and move down to here. And then we'll do a dimension from this point. I use D for dimension there. From this point here to this point here, and we're going to make that 2 inches, right? That's the same. That appears to be fully constrained now. Nothing can move. Now I'll make another line, pressing L again, and we'll go over from the right this time. And this is going to give us some good snaps all the way down, right? It's going to snap to 90 degrees. You could make it 90 degrees artificially, but it's pretty easy this way. We'll go down here, and we'll do it just like that. And there's our geometry, right? That appears to be about the same as what's on here. Okay, so we'll check this, and then we'll go ahead and extrude it. And now if we want to click this, all right, hold on, it's not going to want to extrude, right? Because we just clicked this. So let's go ahead back to this sketch, and let's change something really quick. Of course, we could, if we wanted to extrude this, we could select both faces. But if we wind up adding faces, in the future, or adding more geometry in the future, that might not be added to the extrusion. So we want to set ourselves up for success with future iterations. So let's go back to this sketch. And let's go ahead and use something called a trim feature, which is basically going to make this all one opening here, right? Because the extrusion works based on openings. And so right now you've got 2, right? This will cut through, and then this also will cut through this sort of U shape. But if we go ahead and use our trim tool, which will trim, it will find geometry between points or between intersections, and it will remove that if you click on it. So now we've got one area here, right? If we select that face, it's one thing. So we go back to this extrude, and it extruded the whole thing just when we went ahead and when we, oh, actually we may just have to click this. Let's see. Yeah, when we went ahead and clicked that, it's just going to extrude that. And now if we go ahead and add, go to our climb hook infrastructure there, if we go ahead and add like a rectangle or something here, or we'll make it a corner rectangle, right? If we wanted to, for some reason, add something to this extrude, that would be added in there, I believe. Actually, it may not be. We would have to add it manually, but we'll go ahead and undo that. But I guess I just disproved my point there, but yeah, we'll go ahead and delete that. Okay. But right, if you did want to make changes, like if you wanted to make a line here, that would probably be added to, oh no, we selected the wrong thing, right? It's got to be faces of climb hook infrastructure. So now that's just going to be selecting this, but if you wanted to click that, it'll do them both, and now you're good, right? But we don't need this, right? And we don't need this thing here for now. So we'll just go ahead and go back to our extrude and select faces of climb hook infrastructure, and that should give us the whole thing. Although, oh, you know what we need to do? We need to make a line under here to edit that. But why don't we just go ahead and just click that face at this point, and then we'll go down here and select through all, right? And that'll ensure that if we change the thickness of this, we don't have to worry about compensating for that with the extrusion distance and not having it go all the way through. So now we have our geometry here, right? This is starting to look a little bit similar to what we have here. It's starting to look a little bit similar. So next thing we need is these holes, right? And these holes are 1/4 inch right here. And it appears, what do you guys think is the dimension here? I'm going to call it at another 1/4 inch. Actually, no, it's 0.5. Okay, and let's check if that's the same to the other side. Okay, 0.5. So I'm going to assume that they're all 0.5 from each edge, but we can test that real quick. Just let's measure this one down here. That's 0.5. And this is 0.5. And if you wanted, you could go and measure each one. I'm just going to go ahead and make sure these are on the same plane here. Right, I'm going to make sure these are on the same plane here. So the dx between them should be 0. And it is. So these are all going to be 0.5 from each edge. This appears to be square from the edge there. So we'll go ahead and we'll make a new sketch, right? It's important to keep your different sketches separate, I think, because that way if you want to change one thing, you don't screw up the rest of your design. So we'll select this as a sketch plane, and then we'll go ahead and make a hole up top here, right? And we're going to dimension that to 0.25. And then we'll dimension it to the wall here at 0.5. And we'll dimension it to the wall here also at 0.5. Just like that. And now we've got ourselves a hole. And so we're gonna need 2 more holes. And now we could just make 2 more holes, right, just like that. But I think there's a better way to do it, and that's using a pattern. So if you go ahead and click linear pattern up here, and you click this entity here, you can go ahead and you can select how many instances you want of this entity, and then the spacing between each instance. So we're going to go 2 here, and we're going to go 2 here, and we're going to flip this direction, and we're going to make this dimension. Actually, we can change the dimension later. So now we can see we've got a rectangular hole pattern there. So we're going to go ahead and this is 7 inches long, so we'll make it 7 minus 0.5 times 2, right? That's the edge distance away from here. So 7 minus 0.5 times 2 is 7 minus 1, which is 6. Right, and we could do all that math in the dimension tool. We don't need to, though. And this is going to be 3.5 minus the same thing, so it's going to be 2.5 to get it on that same dimension. And now we've got 4 holes here. We don't want 4 holes. We only want 3 because we've got brackets here. So we'll just go ahead and click this geometry and say delete, right, or backspace rather. And now this is going to show up as unconstrained, so we can just go ahead and go fix. And we can fix that in place where it is. Yeah, why don't we just fix the center point of that? That may solve the issue. No, okay. So it's possible that that's conflicting. Well, it won't conflict, but it'll be like extraneous, so it's going to dimension to multiple things. So what we can do is go horizontal and constrain it to be horizontal with this, and then it'll automatically be vertical with this top one here, right? That's part of the dimension there. So yeah, we constrain it to be on the same horizontal line as this point down here, and now we've got a fully constrained set of holes. So we'll go ahead and extrude those, right? We'll select faces of sketch 1, and actually let's go ahead and rename this. We'll name it hole standoff holes. Now you don't need to name all of your sketch points. I usually don't actually, but sometimes if you're going back and wanting to change things, it is really helpful to have that be there. So if we go ahead and click just the sketch, it'll select all 3 of these. Onshape's pretty good about that, especially with hole patterns. And we'll go ahead and go to through all, right, just so that we don't have to worry about messing around with lengths and depths. And then we'll go ahead and make a check mark. And now I've got one step closer to making this mirror reality. Now this is it, actually. We're not going to make these bracket holes, but we do have these fillets, right? These fillets on the edges, which that's more of an aesthetic thing than anything, but we'll go ahead and create those anyway. So what's the radius of this fillet? I'm thinking like 0.25. Yep, okay, so radius is going to be 0.25 inches. And we'll go ahead and copy that fillet radius onto this corner, and this corner. This radius actually has a function, right? If your climb bar comes down a little bit like this, it might help it guide onto there. That's, a little bit more, a little bit less useful than, but at least it has some sort of function, right? It's a little bit less useful than this ramp here with a large surface area, but it's still, it looks pretty and it helps it do stuff. These ones aren't filleted because this is where it connects to the mounting bar, so that's going to be, go straight down. And aesthetics are important when you're designing. It helps your designs appear professional and well thought out. But aesthetics shouldn't, they should follow, or aesthetics should not be your top priority, right? Especially if you are still working on making designs that work, right? If you have a design that's pretty but it doesn't work, nobody's going to see how pretty it is because it's not going to be working to show them. So we'll go ahead and go back here, and we'll make these fillets. So what we're going to do, and you could do this in the boss base sketch, right? If you went here and you went to the fillet tool and you went here and you filleted this edge, right? It's going to automatically make it 0.25, but you can make it a different dimension, right? So you could change that there. But right, you could do that there, but I don't want to do that there because usually what you can do that's much easier and actually much more easy to edit is just go up to here in the part surfacing toolbar and select fillet. You could also do a chamfer, which is like a flat edge off. You do a fillet here, and we'll click this edge here, and we'll change this to 0.25, and then we'll select the other edges we want to fillet as well, right? And that's going to give them the same dimension, just like that. Awesome. So now we've got all these edges filleted, and this looks pretty darn tootin', pretty close to the same thing. Another thing I think I want to do is actually, is it worth making a little bit of a chamfer here, right? Like making a line coming across here. Let's check that out in CAD. Let's go chamfer, and we'll make this here, and we can make it like 0.5 maybe. Is that worth it? I don't think so. I think it's actually better to have the climb bar sort of slide on and then click into place. That might give you a little bit more security. Now your robot's not going to be tipping forward, and it does depend on where the climb hooks are placed in the CAD, but your robot's not going to be tipping forward so much that you're going to need a lot of surface area here. But it is nice to just have that extra security from it clicking into place and having more surface area on the bar. Now this dimension for this hole we got was just the climb bar, like plus some sort of tolerance. That way we can fit on, but don't have to worry about being too tight on there. That's at least the idea. So now we've got this climb hook, right? And we don't have these bracket holes. We'll add those later. But what we do have, we have this climb hook, and we'll go ahead and we'll make an assembly for it, right? So we'll go back to here, and we'll go to our climb hooks tab, and we'll make an assembly. We'll call this climb hook assembly. I know, very creative naming and very creative spelling as well by me. But we'll go ahead and go up to the top of this assembly, and we'll insert our hook side plate. Now it's going to be the one that we did here, right? It's going to look like that. So we'll go here and we'll insert that just there. And we could use this 0.5-inch hex as a standoff. We'll actually have to insert two. We can insert a second one. We could use this 0.5-inch hex as a standoff, but we actually don't really want to. And now these are the wrong directions, so we'll go ahead, right when you look at the top, this is not the top of them. The top of them is this, and the front of them is this. So we'll have to rotate them 90 degrees up this way. And then we'll also have to rotate them 180 or 90 degrees this way. No, the other way. Have to rotate them this direction 90 degrees. Yeah. All right. And now we'll go ahead and move them to the right spot, right, just so that they're in the right place. And we'll go ahead and make that, like, have the origin be right about there. And this will be our fixed component in the sketch. So we'll fix that in a second. And we don't have to worry about aligning these perfectly, but just for now as a reference, we'll use that way. And now we'll go ahead and go, next thing we have to make, I think, and if we look at our hook assembly reference, hook assembly reference for reference, you can see that we've got, before we worry about mounting, we've got these hex bolts. Got these, or not bolts, they're hex standoffs, right? And these are, let's check how long they are, 0.5 inches, selecting that edge right there. So 0.5 inches, that's pretty reasonable, and we need 3 of them. So let's go ahead and make, and remember this is it's a 1/4 inch hole, 0.25, and then they're going to be 0.5 inches wide. Okay, 0.5 inches wide. So let's go back to our main assembly here, and we'll go ahead and go make a new part studio, and we'll call this 0.5 inch hex standoff. Okay, 0.5 inch hex standoff. And now we're going to go ahead and make this. So you can use a common off-the-shelf component here, right? You could go to AndyMark or VexPro and download some hex shaft. It would be effectively the same, and you really don't have to worry about doing that. If it takes you less time just to make hex like this, then go ahead and make hex. It really, it's not a huge deal. It's actually going to be faster and more efficient to do it this way, unless you have hex that you already have in your design that you're going to be able to modify quickly and easily. But yeah, so we'll go ahead and go here, and first thing we're going to sketch is that cross section there. So make a new sketch, go on the top plane as usual, and then we'll go up here to polygons. And we'll go ahead, there are a few different ways to do this. One that's inscribed in a circle, so it touches a circle on the outside, and the other one that's circumscribed, so the outside points touch the circle. We'll go with the inscribed polygon, just because we want the hex to be 0.5 from either side. So we'll go here, and then we'll fix it to this line here, right? It's going to automatically give us a hexagon, but then we can decide how many lines we want. I'm not clicking and dragging anything there, just moving my cursor. So I'm going to move down to 6 and click again. And you can always change this if you double click this value here. We can make it 7 or 6, or we could set it to a variable if we wanted to as well. Now we're going to go D for dimension, and we'll make this circle be dimensioned at 0.5 inches, and that's going to make it smaller. And we'll make another circle inside for the inner diameter there, and we'll make that at 0.25, right, 0.25. So here's our hex. That's our hex sketch, right, not too complex. We'll go ahead and extrude that up, and we'll extrude it however long we need, which is 0.5 inches, right, and then we'll make an appearance. We'll fix the appearance so that it looks nice, looks pretty, and we'll make it look like that, right? So there's our hex, right? Pretty good, pretty good, pretty good. So now let's insert a few of those into our assembly, and we'll just insert one for now because I want to show you guys how you can copy paste those. But we'll insert one. This is the one that we did, not this one, but they're the same effectively. But you've got this, and what we're going to go ahead and do is we're going to select this just by clicking on it, and then we can right click and say copy, and then right click and say paste, or we can just select it and use Control C, and then Control V to paste. And we can do as many of these as we want, right? And it'll go where our mouse is. But we don't want these, we just want 3 for now. And now we're going to use mate features. First thing we have to do is actually fix this component though, that way nothing moves around. So we're going to right click this and say fix, right? That's going to be our fixed component. Now if we try to drag it around, it won't move. So let's go ahead and use our Fastened Mate, and we'll start from here. We'll select this hole, which matches up with this hole, and we should be good like that. Yeah, that'll give us a hex here. Actually, you know what we can do? Instead of using these other ones and making more mates, we can just go up here to the replicate function, and then click this, and then when you go to faces to find matching, and then you select this face, and it'll find holes or geometry that matches the mate features. So it's going to really find these other 2 holes, and it's going to give us parts on those geometry points there. So now we have 3 holes here. We don't need these extra 2 things. We really only need 1. And that replicate feature is a really good tool for assemblies, especially ones with a lot of the same piece. Like you can use it for bolt patterns or other hardware stuff, and we probably will use it for other hardware stuff in the future. So then we'll go to this Fastened Mate here, and we'll go ahead and click this hole, and click this hole that corresponds with it on here. And if we needed to do any sort of offsets, we could, whether it's in rotation or any of the other 3 degrees of freedom, any of the other 3 degrees of axial freedom. But we're good for now. We'll just click that. So now we've got this assembly here, right? And that's all good. Next thing we're going to need to do, and let's go ahead and look at this. Next thing we're going to need to do is add our brackets, right? These are brackets. These are right angle brackets. And let's go ahead and see if we can find these online. So let's first go ahead and go to, where do you guys think would be a good site to find these? Let's go to VexPro first. And those ones that are in this CAD are from AndyMark, right? You can see that they say AM, which is a clue. It means AndyMark. But we'll go up here to VexPro just because I want to see if I can find something else. And we'll look up right angle and spell bracket. All right, we'll go there and we'll see what we can find. All right, so it doesn't appear that we have anything that will work for us in this. Yeah, it doesn't appear that we have anything that will work for us in this kit here. Maybe if we go ahead and look up just bracket, that may help us out. Sometimes you gotta change the search parameters. I guess we already found that. Okay, so yeah, none of this looks useful to us for our purposes, at least today. But this stuff is going to be too flimsy here, right, like this. We could look up gusset as well. If we look up here for reverse frame gussets and mounts, see what we've got there. But I don't think there are going to be any 90-degree brackets in there. If we look through the picture list, yeah, no. Okay, so let's go to a different site. Let's go ahead and go to AndyMark. We'll go to AndyMark. And that's here. I also have AndyMark bookmarked because I'm a gamer. We'll go right angle, my God, bracket. Okay, what have we got here? Let's just search bracket. scroll for a bit until we find something. Just keep scrolling. Here we go. This looks like something interesting. And I think this might be the same thing that's on here. Yeah, there's definitely a possibility that that is. We can also try going to the Thrifty bot. Go to the Thrifty bot. And here we've searched already L-gusset, so we'll go ahead and search bracket. Okay, so it doesn't look like there's any sort of bracket here on Thrifty bot that will suit our purposes. We could also search McMaster, but I think this one should be good enough for our purposes, right? 48 millimeters tall, 1.89 inches. Thickness is 0.09, right? That seems pretty good. Seems pretty nice. And we'll go ahead and download this CAD file where it's got the option to. So we'll click this, and we'll download the CAD file, right? It's going down here into our downloads. And we'll go ahead and import this into our document. So we'll go up here, import, and we'll do the one that we just worked on. You guys won't be able to see my file explorer, but I'm selecting this file that I just opened, and I'm going to import it to this document. Don't need to worry about any of these, right? And it'll import into this folder that I'm currently in here, right? It's going to be right there. And it'll also import a step file into CAD imports. If we go here to CAD imports, it'll bring that, right? And we've got two of those because I imported one for the other, for the reference build, basically. All right, so now we've got this bracket. Let's go ahead and add this to our CAD assembly here. All right, we've got two of these, so we'll insert two of them. But actually, in the other assembly, we've got four of them, and I think that's the thing to do as well, just because they're not super thick, and we'll want, you know, some more distance between them. I think we should shoot for a way to have these holes be 1 inch apart. That seems like a feasible way to do it. So have the holes be 1 inch apart. We'll go ahead and insert 1, 2 of these. Okay, and now this is going to be something we're going to be doing where we can have our holes actually come from having these in the assembly. And we could go ahead and make our holes actually on here first, and that way we know that they're 1 inch apart. Or what we can do is we can go ahead and use our Fastened Mate. Use our Fastened Mate from here, and we'll have to select the bottom of this because this radius, you can't select the true bottom there because it won't want to select that way. And then we're going to go ahead and mate it to the bottom corner here, and that'll put us like that. We'll rotate this, not that way, the other way, right? And that way we have this sort of type deal. And I think we're going to have to offset it in the X direction, right? That's upward. We'll offset it 0.125 should be maybe a good assumption. Is that going to be accurate? Might need to be more than that actually. So we'll try 0.25. Is that going to be too much? I think it will be. Yep. So let's try just random numbers until we find something. Honestly, that's what you have to do a lot of times in CAD. Now 0.15 seems to be a good solution, so we'll go with that. So you've got this Fastened Mate, but also we want this hole to be this distance away. So what's the distance to this hole, right? Center distance is 0.315. Oh, that's a weird number. So we'll just click this and we'll copy it, right? And when you use COTS parts, sometimes you will get weird geometry like this. Now this is not necessarily the best way to do it, but sometimes, you know, you just have to. I'm just trying to show, you know, often how you can use spacing in order to create holes. So we want to put this in the right place at first. Let's go ahead and go and edit this mate, and then we'll move it over. So we have this center distance. It's probably going to be, since this is 2 inches, and we want 1 inch between the holes, we'll move it over 0.5 minus that thing that we got. So we're going to move it in the Y direction, 0.5, that's negative, 0.5 minus this, which is a funky type number, but when we do that, it should give us, and we'll flip that, actually we'll make this negative, and we'll make this positive, like that. Flip that, and this should take us so that we can have our thingy be in the right spot. And now we can just mate this one to this one, and we should be good. So we'll go fastened here, and we'll mate this geometry here. We'll make this central mate connector there. Right, and you want to make sure that the z-axis here, the central axis, is pointing towards where the other one would be. We'll mate this one. We'll find the corresponding mate connector on this one, and that'll mate them together like that. We will have to do some changing like that. And now this is going to make them look like one thing. We don't want that. We want these holes to be 1 inch apart. So we're going to have to offset this in the z direction by a certain distance, and we'll find what that distance is, but we'll call it 0.5 for now. We want it to be negative 0.5. Right, because you're moving it away from where the z is. And that may actually be, no, I don't think that's correct. So let's check the distance between these holes. Center distance is, okay, and we'll just go ahead and copy that again, right, with Control C. And then we'll, go ahead and do that Fastened Mate, and we'll do 0.5 minus 0.5 plus, oh dear, I did the wrong thing there. Yeah, okay. 0.5 shift plus, and then paste that in, and that should give us a distance of, oh dear. Oh, well, yeah, no, it should be the other way around. It should be this minus 0.5. Yeah, sometimes math do be hard like that, and that should give us the proper dimension there. And this should be negative. There we go. Is that not going to do it? It's going to take a second to load here. There we go. So is that, let's see what the whole distance here is. I think we would also have to compensate for that. Yeah. So we'll have to, okay, this is proving to be a little bit trickier than I thought it would be. Let's go ahead and try a different approach. Let's delete this Fastened Mate. Never be afraid to, scrap completely what you're doing and try something else, because usually you know better than what you know. So yeah, we'll make a mate connector here, and we'll mate this hole here. We'll mate it to this hole here. And we're getting a little bit of loading issues right now. We'll mate this hole here to this hole right here. And now that's going to put them right in each other, and then we can just offset that by 1 inch to get our distance. And wow, look how easy that was. I can't believe I didn't think of that in the first place, but you know what? Sometimes that's the trick right there, is just thinking of things. So now if we look at this hole and this hole, they should be 1 inch apart. Perfect, perfect, perfect. All right. And if we look at this hole and this edge here, it should be 0.5 inches. It's not. And that may be that we just didn't take this into account here because we were mating from here. And that would be a case of just mating this hole directly to this bottom corner here and then moving that over the corresponding amount. Sometimes when you're trying to balance all different variables, that can be a little bit of an issue. Let's actually go ahead and change these mate connectors. We'll change these mate connectors, and I'm going to fix this. This should be, we'll fix it. We'll figure it out. We'll mate this back here, this back one down here, to this connector down here. And that's gonna. It didn't select either of those. Sometimes it do be weird like that, but yeah, we'll make this to this connector down here, and then we'll also select this one. And that'll make the two, and then we can use our offsets. Okay, so now x is going to be in a different direction. What we're going to need to do it is negative y. So let's try negative 0.25 just as a reference. See where that gets us. Okay, it needs to be positive there. Okay, maybe we need a little bit more than that. Let's try 0.3. See where that gets us. No, it needs to be positive. I don't know why I keep being dumb. Yeah, and that appears to be accurate. All right, and then we'll move it over in this direction, 0.5, which is going to be x. Right, because we want that hole to be 0.5 away from the edge there, and that also needs to be negative. Sorry if you guys are, if I'm having any influence on your CAD ability whatsoever, I deeply and profusely apologize. But yeah, so now we've got these, and they will be mated to each other, so once we click check on this is going to move to 1 inch away from that other hole. Right? That's pretty good, pretty cochino. All right, if we look at this, it's going to be 1 inch distance, and if we look at this, it's going to be 0.5. So that was the minimum distance. We got it right the first time. I don't know why I'm actually dumb, but Okay, you guys disregard everything I just did, although that is another way to do it, so I was able to show that. But yeah, so the Y direction is going to be 0.5 inches, and that'll be the same for this one, because that's 2 inches. Okay, so now we have our holes on one side, and we're going to do something new. We're going to do something called an in-context edit. And that's what that's going to allow us to do, is to make these holes for for putting bolts between and adding these gussets. All right. And sorry if this video takes a little bit longer. You're welcome to watch it on 2x speed, just to try to follow along a little bit more closely. But yeah, so let's start. And we'll right-click this part. We'll right-click this part and say Edit in Context. Right. And what that's going to do is it's going to bring us into a context of the assembly. Right. With the part highlighted. So let's go ahead and we'll go, and it's upside down automatically because our part is in a strange configuration as compared to the rest of the assembly. But let's go ahead and make a sketch for the holes. We'll make it on this plane, and we'll call it bracket holes. We'll call it bracket holes, and I keep pressing the check mark there. You don't need to do that. We'll call it bracket holes, and then we'll just go to these, and we'll use something called a convert feature or a project feature. And that literally allows us to select geometry that already exists and project it straight onto our sketch plane, just like this. So we click this hole, and we click this hole, and bada bing, bada boom, we've got our holes for our brackets. They're put right into the sketches, right? And that'll make this an official context because we're using the holes that are already there, or that are from an in context part. And let's check the diameter of these holes. Okay, so they're 0.15. We're probably going to want to put a 3/16 bolt through there. So let's make another circle that is going to be 3/16 in diameter. And we can always drill through these brackets there. Actually, you know what? We'll do 8/32s to hold these. No, we'll do 10/32s. We want some strength. We'll do 3/16. We can just drill through these brackets when we manufacture this. And then we'll make another rectangular pattern. And we'll go this way. And we'll only have 2. And then we'll go up as well. And we'll have 3 up. And then what we'll go ahead and do is drag this down until it snaps to this feature, which we can actually get it to do in a second, but we'll just check mark that, and then we'll use our constraint here, right? Coincident means 2 points are on the same point, really. So we click this, and then everything should constrain, and we'll actually have to delete this dimension that was added there. All right, so now we have our hole pattern, right? And that's going to go ahead and give us these holes. So if we go ahead and first let's go back to our bracket hole assembly, or bracket hole sketch, and let's select all these inner holes, and we'll make them something called construction geometry, which means it's geometry that can't be used in surfacing. So it's not a real part of the sketch, but it's what you base other things off of. So we'll do that, and you can either hit Q or just go here and say construction, and that'll make them into dotted lines. And when we go ahead and extrude those, we can just select this sketch rather than having to click all of the different faces. So we'll extrude this. No, that's a sketch. We'll extrude this. And we'll just extrude bracket holes and remove them. And we'll go through all. And now, that should happen in the other thing. So if we go up here and we go update context, this other one will have those holes. And now we can see that these holes have shown up in the assembly. So we'll go back to our assembly just by clicking this. If we click this X, we would just go into the normal part studio. But we'll go back to our assembly, and we can see that we've got these holes in our CAD. And now what we can do is we can just go ahead and add more brackets. So if we select that, and then we do Control C for copy, and then we can paste more instances into there. We won't use our replicate feature here because it'll make a new mate for each one of these holes, and we'll have to delete all those. Although that may just be quicker than doing what we're going to do, but yeah, that's up to you. So we'll click this bottom hole here, click this hole here, and then we'll flip the mate connector that was the wrong thing. We'll have to drag that away. Let's go ahead and click this here, and then click this hole here. And then when we flip that, it should be good geometry-wise. We'll do the same thing here. And we'll click this, and there we go. Right after we do that, now we've got our completed hook. Let's go ahead and compare that to what we have here, And it's pretty much bang on. That's the idea with this, is to just replicate this thing. That way we don't have to do much thinking. What we are going to do is add hardware to this. We're going to add hardware, and it won't take too long. Let's go ahead and check for the hardware we need. So we'll need a quarter 20 bolt, right? This is a 1/4 inch bolt, and it'll go into here, and it'll come out. Right, there's a 1/4 inch hole. Let's see how long we need it to be. We need it to go from here to here. So that's going to be 1 inch long. We'll need a 1 inch quarter 20, plus however much distance we'll need for a nut. So like 1 1/4 or 1 1/2. I think 1 1/4 will be appropriate. And we're also going to need a 3/16, a 10/32 bolt, a 10/32 bolt rather. And we'll go from here to here just to check how long we need. Okay, 1.18. We'll do 1 1/2. So we need a 1 1/4 quarter 20 and a 1 1/2 3/16, or 1 1/2 10/32. So we'll go here and we'll go to McMaster-Carr. When you need bolts and nuts and stuff, you'll go to McMaster-Carr. And we'll go 10/32 bolt. We'll find the 10/32 for us. And I said it was going to be 1 1/2 inch, I think. So that's what we'll go ahead and look for. 1 1/2 inches. Alright, so my little search function failed there, so we'll go ahead and go to fasteners here, and we'll go to socket head screws, and always steel socket head screws, and that's going to give us the bolt we want. Okay, so now we'll scroll down until we find 10/32. It's going to be a bit of a ways just because it's going to go by size. It's going to give us 8/32s, 10/24s, and 10/32s. We needed 1 1/2, so we can go ahead and use that, and we'll need it to be partially threaded is fine. So go product detail, and I think I probably already have, like 5 copies of this step file on our computer, but we'll save that. And then we'll go back here, and we'll find a quarter 20. Find a quarter 20 of the right size. And I think we may have to keep scrolling for a little while, but quarter 20 isn't, here we go, quarter 20, and we need 1 1/4. And most quarter 20s are going to be fully threaded, although they won't always be. See, that's the size of a quarter 20. We'll go down here and we'll also save that. Now we'll also need a 10/32 nut. So we'll look that up. And here we go. We'll go to hex nuts. And we'll find our 10/32 nut right here. So we'll go here. We'll go to our product detail there. And we'll download that step file. Again, I probably have quite a few copies of this, but then we'll go also here and we'll go quarter 20 nut. Go to hex nuts, and we'll go to medium strength here. And then let's see, I think we don't need zinc plated, although that may be, yeah, we can just use these steel nuts here. We'll go to product detail, and we'll download one of these as well. All right, and now we'll go to here, and we'll make a folder called hardware. Make a folder called hardware, and we'll go ahead and go into here and we'll import all 4 of these. You guys can't see my screen, my file explorer again, but I'm just selecting all 4 of these and importing them into our hardware folder here. And you could import them to the document or combine them to a single part studio, it doesn't really matter. We'll wait for that to go ahead and import. And once that finishes, they should start to show up in here. Well, they may show up outside of there just because of where we were or like where our current view is. I wonder. Oh yeah. So they just went straight to the home screen here. So we'll just have to drag them all into climb hooks folder. Drag them into the climb hooks folder. And then we'll drag them into the hardware folder independently in there. You can see our hardware folder there. We'll drag these in, and we're good there. Okay, now if we go into our hardware folder, we can see that we have all of the appropriate bells and whistles, and I think these failed to insert. Yeah, there we go. Okay, we can see that we have all the appropriate bells and whistles in there. These do not want to go in. That's just because they're still loading. All right, cool. There we go, 4. Awesome. So now we'll go to our assembly, and we'll just go ahead and insert all that hardware that we'll need. Now sometimes it is tricky to find, so let's just go ahead and find, let's just first search up black. Right, and I think that will be, that's both of these, so we can insert one of these and one of these as well. And then we'll also look up low, because these nuts are low strength, or they're labeled as that. This is going to be our 1032 nut, and then we'll also look up mid, which I believe will match our quarter 20. Let's go ahead and check. Okay, we'll just search keyword grade. Using keywords from your title is a really good way to just find what hardware you're looking for. Okay, now that we've inserted those, we can go ahead and add first our quarter 20s, right? So we'll do a Fastened Mate here. And sorry if this lesson is running a little bit long. If you guys want to pause it and finish it another time, I'm totally fine with that. We'll go ahead and insert our hardware there, and it looks like we calculated the length to be just about right. And then we'll also go ahead and mate this nut here, find the center of that there, and we'll mate it to this hole there, right? And then we'll also flip that around. And then we can use our replicate functionality. We can use our replicate functionality to duplicate these mates across this face, and that should do just like that. That should be great. Should be awesome. And then we can do that again and replicate these nuts. Okay, so now we've got these, and we can go ahead and finish with our 1032s, right? And after this, our hardware, our complete assembly will be complete, as the name will suggest. But yeah, and you don't really need to add too much hardware to your CAD. Let's check the distance on that. That's pretty good as well. You don't really need to add too much hardware to your CAD. It's honestly not something you need to worry too much about. But adding some where it counts, like people would need to know that these are, this length of nut, or this length of nut, this length of bolt, when they're making when they're making parts orders. And so that's kind of important that needs to be said there. We can go ahead and replicate this across this part, or this face, and we'll find matches in this face, and it'll create 6 there. And we can also go ahead and replicate this across this face and this face. And awesome. Now our assembly is complete, and there we go. Right, that's not bad at all. That's not bad at all. And this looks actually like it's got a few more bells and whistles than this even, which is pretty nice, But yeah, overall adding hardware is not like super necessary, but it is quite nice to have in the CAD. So now what we're going to do is we're going to go back and let's go ahead and check what our reference here looks like for the elevator assembly. Right, let's look at what our reference here looks like for our elevator assembly, and we can see that we've got our hooks pretty much perfectly lined up with this here. So it looks like what we did is just mated this to this edge here, or we might have mated this, the center of this, to this edge here, and then offset it by a certain amount, which would have been like, maybe 2 inches. It would have been offset. That's a possibility as well, but we'll go ahead and we'll try to replicate that. We've got one on each side, right, and they're spaced as such. We may actually, in real life, we would have cut these gussets down. That way we can have these farther apart, because there is a thing in the middle of the climb bar, so the farther we can reach, the easier it is to latch on and to align stuff. But yeah, so let's go into our assembly, and we'll go here. Right, we're done with our climb hooks assembly there. We've got all of our different parts, as well as our hardware, and we'll go into our elevator assembly. That's prompting us to add hooks. Awesome, we'll rename that once we're done. So let's insert, we'll go to assemblies, and we'll look up hook. Now we have the climb hook assembly and then the hook assembly. Climb hook assembly is what we've been working on. The reference hook assembly is what was imported. So we'll insert that, and we'll insert 2 of those. All right, awesome. So now we've got 2 climb hook assemblies, and let's use one of our fastened mates to tie that down to this. I figure, I don't know, I guess we can mate, yeah, why don't we go ahead and mate the edge here. We'll mate this to this bottom plate here, and we'll go from there. Actually, no, you know what we can do? We can mate it to here, and then because that's aligned with our hole, we can just move it over 0.5, and it will be centered. It will be perfectly centered and perfectly aligned. So that would be fantastic. Actually, hold on. I think we selected the wrong mate connectors there. We'll go ahead and click this one, and we'll go here, and we'll click this one, and then we'll have to offset it by 0.5 inches. We'll offset it by 0.5 inches. And let's make sure that, yeah, that's aligned. Okay, we'll go -x, -0.5, right? Because the x is pointing this way, so we'll move it 0.5 in the other direction. And sometimes it just doesn't want to cooperate, because it may be the mate connector on the second part. And if we check that, then we'll have another one there. And we could use, replicate features like that. But we could also, just go ahead and do the other mate ourselves. It's not that much work. Click this, and click this here. And then we'll have to offset that by, this appears to be, we'll do it, I think, in the x direction again, 0.5. See where that puts us. No, that is wrong. Okay, we're going to have to do in the y direction, possibly negative. We'll see how it goes. Yep, negative. Awesome. And we'll check that, and there we go. We have our hooks in the CAD. So if we go ahead and look at that, right, we've still got sliding action. When we slide this up, everything else comes with it, even the hardware, which got left behind for a second there, but then it remembered that it's stuck to it. They're stuck with each other. So yeah, if we go ahead and raise that up and down, we can see that it does, in fact, move, right, just like that. And it has hooks on the end, so now it's usable, right? So this has been sort of just an example of how we kind of use CAD, what the workflow looks like when we're doing CAD for robotics. This was a smaller assembly, and I kind of took my time and went through it. Usually I would do this a little bit faster if I was doing it on my own. But yeah, so doing things like this, right, you're making custom parts, you're making assemblies using custom parts and COTS parts, and this is actually a custom version of a COTS part, right? So Hex is coming off the shelf, but we didn't just download the STL file or the step file from online. We went ahead and made our own, which is effectively the same thing. But yeah, we used a combination of COTS parts and parts we made ourselves to create an assembly that eventually wound up on the robot. And if we check the whole robot now, why don't we go ahead and do that? Because this assembly should be inserted into that whole robot. Let's check it out. See what it looks like. And wow, there we go, right? What had no hooks before now has hooks, right? That must be Shakespearean or something. I thought of that on the spot. But yeah, so there's hooks here, and when we move this up and down, right, the whole elevator carriage will move up and down, the whole first stage. So that's good like that. And you can see actually that, well, so this assembly is a sub-assembly, right? So this assembly was inserted into the main assembly, and so now it has, the same properties, the same parts, and when one is updated, the other one updates automatically, which is another great feature of Onshape. Other CAD softwares can do it, but you have to sort of update files and then save them for it to work, whereas Onshape does it automatically, which is pretty great. But yeah, you can see there, that's our completed assembly, just like that. And let's go ahead and go back to our lesson here and finish presenting this. All right, so what did we learn, right? CAD really is not that complex. What you're doing is you're making some parts custom, and you're also editing some parts. Like we saw, we edited a few. Actually, we didn't edit any COTS parts in this lesson, but that is something you do if you needed to make a bolt shorter, or if we needed to, for example, make the holes in those brackets actually wider. We could have done that as well, because those bracket holes might have needed to be drilled out for a 1032 bolt. So in real CAD, you would go ahead and make those wider, but I wanted to keep the time constraint relatively tame. I know we've went past, significantly past what we usually do, but I think this has been a good example of sort of how the CAD workflow works for robotics. And this was a small assembly, pretty trivial, pretty inconsequential, but I think the workflow is the same as anything big, right? It's nothing complicated, you're just making things to solve a problem. And our problem was that, our climber went up, but couldn't actually do anything, right? So yeah, we didn't do any design today, we just did CAD, right? We didn't do any problem solving or any critical thinking or anything like that, but we learned CAD. And I think learning CAD helps you translate the designs that you'll come up with later into the CAD, right? Into something that people can see and understand and then review as well. So your design, should be used in CAD and translated into CAD in a format that other people can improve and that you can improve. But yeah, so what we did, here was sort of wrap up our CAD unit. I think knowing what we know now, that's really enough. That's pretty much all the CAD skills that you're going to be using when you're doing robotics. There are other skills as well, but really all the main ones were covered here, and the rest you're free to explore on your own because you will find them. If you spend time and learn the software and learn to enjoy it, I'm not going to make you, enjoy it, but like if you want to, if it's something that interests you, then I would go ahead and, just spend time. And the more time you spend, the more things you'll learn, the more quirks and nuances, and the more you'll actually become familiar with the things that we've talked about over the past few lessons. But yeah, so I think right as we conclude this, next time we'll start working on a project, and that's going to be combining sort of what we did during this CAD unit with what we did during the first unit, which is talking about practical context-based design, like how do you actually design for FIRST Robotics? And now we know how do you design for FIRST Robotics, and we know how do you make CAD for FIRST Robotics. So I think when we add those together and start, designing and then using CAD to translate those designs for FIRST Robotics, that should come out to be really special. So we'll have 3 projects, right? They won't be too crazy, nothing too crazy, probably not much bigger than what we did today, but enough to sort of, give you guys a taste of practical design. That way when we get to the actual build season, you guys should be good to go. Of course, you're never going to be able to be fully, ready without practice, but that's sort of what I'm trying to give with this lesson series here. So as always, if you have any questions, please, please, please let me know. I would love to answer them. And yeah, thank you guys so much for watching, and I will see you all in the next one.